Hello everyone, we will now present our project workshop. Here you can see a summary of our work. Cycling through FES is an effective exercise for promoting the recovery of lower limb muscles when their control is altered. Our aim was to analyze the activation profile of the muscles during pedaling and identify indicators of the fatigue onset. Here we can see the common experimental setup for the project. The subject was asked to keep a constant cadence as the resistance was increasing. The analysis was conducted on 3 minutes from the first and last part of the signals, and for some parameters we discarded pedalings with a cadence far from the target one. In the time domain, we calculated mean, median, root mean square value, the integral and fractal dimension, a statistical index of signal complexity negatively related to motor unit synchronization, which is supposed to increase with fatigue, leading to a lower signal complexity and an FD decrease. These are frequency domain indexes we computed. Due to fatigue, PSD is supposed to shift towards lower frequencies, and the PSE and median frequency should decrease. DSI is instead supposed to increase with fatigue.
So although we have observed no standard behavior between subjects, we can recognize a constant pattern. Due to fatigue, the rectus femoris seems to activate before and relax with a delay, probably due to the protocol with increased resistance. For the hamstrings, this behavior is less evident. We would probably need higher interval of stimulation in fatiguing conditions in case of FES. These parameters all show the same increase in behavior due to the higher muscular activation and needed to perform the protocol. The same behavior is shown by indexes computed on tangential forces. We conclude these indexes are not appropriate to be used to highlight the onset of fatigue. FD is sensible to the presence of great motor and unit action potentials which appears during fatiguing contraction. When FD decreases, we can say the prevalent effect is the one of fatigue, while FD increase is related to higher resistance of the pedals. Being the right rectus femoris the most involved muscle in the protocol, we can conclude the fractal dimension could be used as an index of fatigue, since it effectively always decreases in this channel. For the hamstrings, we see a quite opposite behavior, leading to increasing FD values.
For the median frequency, looking at rectus femoris results, we observe a shift toward lower frequencies just for half of the subjects, since this parameter is highly affected by the quality of the signal. In fact, discarding backed cycles, all mean and median frequencies decrease. Regarding PSD and DSI, both show a shift towards lower frequencies as well, since in fatiguing contractions we recruit motor units with slow contraction associated to low frequency components and due to the crosstalk. PSE is an index positively related to the distribution on different frequencies of the power content of a signal. The narrower the spectrum and the higher the synchronicity of motor units in fatiguing contractions, the lower the complexity and thus the entropy. Again, right rectus activity shows an overall decrease in the entropy, confirming that along with fractal dimension, it could be used as an alternative index to the one cited earlier.
Thank you for your attention.